Okay, let's go ahead and plot for V out of t of this half wave rectifier circuit, given that my input is the sinusoid Vm sine omega t. And what we want to notice is that this half wave rectifier circuit uses a component called a diode. And a diode is essentially a two-terminal device made up of a positive terminal called an anode and a negative terminal called a cathode. And essentially, this device, this diode, only allows current to flow in one direction, where if the current is going from the positive to the negative terminal in this direction, it sees a very low impedance, so it passes through, versus if the current is going from the negative to the positive terminal, it sees a very high impedance, so it does not pass through. So let's go ahead and look at this input and see if we can plot the V out of t. And the first thing you want to notice is that my diode is not going to turn on or allow current to pass through unless it's higher than this V threshold. So for this positive hump, my current is going to be flowing in this direction here. So it's not going to turn on until t over 10. So I have here t over 10. So it's going to be 0, and it's going to pop up all the way up here. And then it's going to come back down and go back to 0 at t over 2.5. So here is t over 2.5. And then at t over 2, all the way to t, it's going to be 0 because if you see, my current is going in the other direction. And since it's going from minus to positive, it does not allow current to pass through. So then we'll just see a 0 all the way up to time t. And then again, in the positive hump, it's 0 all the way to t over 0.9 because that's when it hits the threshold voltage. And then it pops up and goes all the way to Vm. So here we're going to have 0, and then it's going to pop up, where again, this here is t over 0.9. Now this hump here, this maximum here, is going to be Vm minus Vt, simply because the diode also attracts some voltage. So this becomes my final V out of t. Thank you.